today. Of course, today, yesterday we started multiple linear regression, and of course, we're actually going to continue from where we start. We got two materials for today. Okay, so there's going to be the first one, and this is called part two, of multiple linear regression. Okay, so um, of course, yesterday I actually walked you through building relationship between response variable and more than one explanatory variable. Okay, the explanatory variable can actually comes in let me just say in a non-linear form or in a linear form. Okay, and of course I walk you through the polynomial regression. I also walk you through a situation where we had more explanatory variable. But today we actually want to consider situation whereby we got two explanatory variable. One is quantitative and the other one is categorical. Okay, and that's what I call using quantitative S and a categorical S. Okay, so in the outline, I'm actually going to walk you through how we make predictions in multiple linear regression, and I'm also going to walk you through the effect of categorical and the quantitative variable. Like I said, um, we got two explanatory variables, and one is categorical situation where one is categorical and the other one is categorical. Okay, how do we handle that? Okay, we're still working with multiple linear regression, and I'm going to give you an example from something that you like, sports. Okay, take a look at this. I want to talk about football now, American football. Okay, the NFL winning percentage. Maybe we actually want to predict the NFL winning percentage. And if you take a look at the response variable, okay, well, the response variable is that, okay, but we got 0.4 and point against. Okay, we've identified the two of them as important variable to be considered for predicting winning percentage. I think you all know do you watch football? Okay, I love football. My children love football a lot. So now we want to consider variables that will make a football club to win. And we have our data, we run linear regression. Can you see what we have? This is what we got. Now, when I first want to start with, maybe I just wanted to understand what I'm doing. I first want to start this. How do we make predictions in multiple linear regression model before I go into the second goal that we call when I have a categorical variable S and a quantitative variable S. But right now, the example that I'm actually showing is how do we make a prediction? What do I want to predict? I actually want to predict the winning percentage. Okay. Uh, what is the name of the football club in Minnesota? Vikings, right? Okay. Now I want to predict the winning percentage for Vikings, and I got some useful explanatory variables like point for and point against, and I run the regression, and look at what I got. Oh my God! After running the regression, this is looking interesting. Point 4 is expected to be negative, right? I mean, sorry, it's expected to be positive because you make a point, right? That will be added to you, right? But point against, what do you see? Negative. Do you see the slope for that? Negative. That is expected. Okay. That is expected. Okay. Now, this is the output. And, you know, if you want to take a look at how significance each of, like, for instance, if I want to know what is the significance of 0.4, I'm actually going to look at the p-value, right? What is the significance of point against? I'm going to look at the p-value. You can see here individually, each of these has a, statistical significant contribution to the winning percentage. And not only that, if you want to look at the R squared, look at that, right? What is that? 88 points. If you multiply that guy by 100, 88.44%, it means so 0.4 and point against explain 88.44%, okay, out of the 100% variation in the winning percentage. And this is actually suggesting we've considered, you know, appropriate variables in this model. Okay, now I want to walk you through prediction now. Do you know I walk you through prediction when we're dealing with the simple linear regression? You remember where we talk about individual prediction, an average prediction. Do you remember that? And I remember we also talk about the interval for that. I remember when we talk about average prediction, we actually want to make a prediction at individual level. If we want to talking about, average prediction at a group level, okay, you want to make a prediction at a group level, but for individual prediction, you want to make a prediction at individual level. And of course, I want to walk you through. I'm going to show you a code now. If I want to make a prediction now, oh my God, take a look at this. I want to make a prediction now. Okay, maybe a particular club. Okay, I know I have information about the 0.4. The 0.4 is 400. The point against is 350. Do you know that if I want to do this manually, I need to first write a model, right? I need to write a model that connect all of that. And I'm just going to be plugging in value. Okay, if I want to write a model, I don't know, the person online, if I write on the board, can you see can you see the board, the person online? You can't, right? Okay, let me see this. Now, I'm going to use this, let's say Y is the winning percentage, and I call it a curve equal, what am I going to write? The intercept, in order not to waste my time, let me just write to 2 decimal, 0.41, right? Okay, then plus, okay, is 0.0017, okay? Maybe this is x1. What does x1 represent in this matter? The x1 is 0.4, right? And I put plus, oh, sorry, not plus, negative. The point against is actually negative. Oh, let me clean this. Okay, then let me go there again. Okay, negative is 0.0015. Okay, x2. And you know what x2 represent this model? Represent point against. Do you know that if I want to make use of this model, okay, if I know what x1 is, what x2 is, I can make a prediction, right? That's a manual way to predict, okay? But we want to make use of R, okay? If you want to make use of R, you're going to write that new data. You have a new data available now. You're going to write less than negative data the frame 0.4 equal to that, point against equal to that. Then you're going to write predict. Okay, please pay attention. This is a code. You see that? Predict.lm. Why do I say predict.lm? Because when I was running the model, okay, if you take a look at this, is it what I used to save it? You can save it whatever you want. Okay, so predict.lm, predict.lm of that. Okay, the NFL.that. Then when I put confidence, please pay attention. When I put confidence, that is average prediction interval. When I put prediction, that is for the individual. You know what I've done right now? The points estimate is going to be the same for both, whether for individual prediction or whether for individual prediction or average prediction. You remember what we did the other time? But what is going to be different, okay, is take a look at this. Do you see the interval for average? Do you see the interval for individual? The interval for average is going to be narrower, and why for the prediction is going to be for the individual is going to be wider. Now, this is a code, in exam. If I ask you to, if I give you data, just like what I did in midterm one, you don't go manually, that's going to waste your time. Okay, just write a code like this, BFF code. Then you're going to see results. Is there any question here? Now, what we're trying to say here, the winning percentage is between, this guy is trying to say the winning percentage is about 58.93%. But using a single value, using a single result is not going to be appropriate in statistics, because a single value could be wrong or right. Okay. And that's why we normally want to describe our result in an interval. Okay. The true value is always going to be in the interval. And of course, you know what we mean here. Okay. Now I want to go into a second goal of this, of this material. Is there any question before I go into a second goal? The first goal has already been achieved, or what I just explained is how to make a prediction using a multiple linear regression model. Any question? And how to make a prediction? How do you define? How do you find? The code. The code will automatically. The code will automatically find the point estimate and the interval. Take a look at that. And the difference between the two is just putting confidence in that one, putting prediction here. Does that make sense? Is there any question? Whether in person or online? Any question? I decided not to delay the posting of assignment 3 because I extended the deadline for assignment 2. Does that make sense? And that assignment 3 will be posted today. Okay. Okay. Now I want to go into second goal. The second goal is in a multiple linear regression, I have two explanatory variables. Okay. And one is categorical, the other one is quantitative. But let's first start from from the scratch, and let's see what is going to happen. Take a look at that. Last time I walked you through relationship between wage and marital status. That's a dummy regression. You remember we did dummy regression, right? Because the marital status, the explanatory variable here is categorical. Whenever you are working with a categorical explanatory variable, like in your module, you only have a categorical explanatory variable. That's a dummy regression. Okay, now we're looking at the effect of being married or not on the wage. Okay, X is categorical. Marital status, that has two levels. Okay, married or single. And of course, the response variable wage is quantitative. Okay, now we got data available. It's a survey conducted in current population survey conducted in 1985, and that was conducted over 534 sample. Okay, we run the regression and we got result. Okay, please pay attention. I need you to pay attention. Okay, now this is the regression outputs. Okay, now there's something I needed to pay attention to in the outputs. You see status single, right? Okay, arrow, it means arrow has automatically coded single as 1. Okay, whatever that show in your outputs, whatever that show in your output is what arrow coded as 1. The level that doesn't show, what doesn't show? Married, right? Married doesn't show. The level that doesn't show, arrow automatically coded it as 0. Does that make sense? And it coded it, whatever it coded as 0 is actually going to make it as a reference point. Reference point. Okay, now, but take a look at this. This is just having a diagrammatical plotting of married and single. Of course, I can say in the picture here, right? You can see in the picture here, This is for 0 is married, 1 is single. Okay. Now, based on the model that we have right now, what is a fitted model? Okay. Like I said, if you want to get a fitted model, you're going to look at estimate. Right now, this is my fitted model. Okay. Sorry, what it says is wage. Hey, so wage cap. Okay, the model now, wage cap equal 9.40. Where is the 9.40 coming from? I did that to 2 decimal. Okay. If I don't tell you to do to 2 decimal, write the whole thing. Okay. So now, can you see that? Now, how am I? And I'm going to write status single. I'm actually going to write. Why am I writing status single here? I'm going to write whatever that is displayed in R. Can you see that? I'm actually going to write. So that I'm trying to pass information across that, you know what, my variable here, arrow has automatically coded or state or, or single as 1. Now, how do I interpret this guy? Please, I need you to pay attention now. Okay. If you take a look at the interpretation right now, based on this model, single workers earn 109 cents less per hour than the married workers. How do I know? Because the married workers, okay, if I want to know what married workers earn on average, please, I need you to pay attention. If I want to know what married workers earn on average, you know what I'm going to do in the model? I'm going to plug in 0. Because you know why? Because arrow has automatically coded married as 0. How do I know? Because arrow is displaying single in the output. Whatever arrow displayed in the output, it has coded it as 1. The one that it did not display, it coded it as 0. Does that make sense? In this company now, married worker earn $9.40 per hour. If I want to get the what single worker can earn, I'm going to plug in 1 into the status single. You know when I plug in 1, you're going to say I'm going to be subtracting. What am I subtracting? 1.09 from $9.40. Okay, 1.09, $1.09. For those of you that are not resident in the United States, $1, 1.09, $1.09 means 109 cents. Does that make sense? Is there any question here? Based on what we've just done right now, you can see the married workers earn more, while the single worker earn less. Okay. Okay. Now the next thing we want to do. Somebody can argue this out. This may not be correct because of the fact we have not also put into consideration some explanatory variables that could affect wage. It is not only going to be a marital status that we affect age. Can we also look at literature? And that is why we want to do this now. Oh my God. Look at what I'm putting now. In addition to status, I had experience. Okay. Adding experience, you know what I mean? I'm trying to incorporate the effects of experience, even though the primary variable of interest is looking at the effect of status, of marital status on wage. But if there exists an important variable that is not included in the model, it's going to be an exercise in futility. Now, when we run that, we got these results. Oh my God, getting this result, this now become a fitted model, right? That become a fitted model, and I needed to pay attention right now. I'm seeing a lot of midterm 2 question here. A lot of midterm 2 questions. So if you don't understand, I need you to ask question. Now, do you know, based on this model, we got an extended model round, right? Do you know based on this model, we can derive 2 models? How? We can derive a model for married workers. We can also derive model for single workers. Okay, what do you want to say? Okay, like if I want to get a married workers, what am I going to do? Okay, when I put 0 for status singles, I'm actually going to have a model that will be in terms of experience only, right? Exactly. Send me a message for extra credit. Now, what I'm trying to say, what is trying to tell us now, take a look at this. Okay, based on this guy, if I wanted to get what is a fitted model for married workers? What he just told me now, I'm going to plug in 0 here. When I plug in 0 here, I'm only going to have 8.86 plus 0.27 experience. Does that make sense? So which means in that situation, I've put into consideration the experience for single. If I sorry, for marriage. If I want to do the same for single, okay, if I want to do the same for single, I'm going to plug in 1 here. Oh my God. Plugging in 1. Please pay attention. Plugging in 1, the intercept is going to change. Because when you plug in 1, it's going to be 8.86 minus 0.9. Does that make sense? The intercept is going to change when you plug in. Okay, go ahead. Okay, this is the best to know. Like, initially I only consider effect of status alone, right? And I introduce experience. How am I going to know whether the experience that I've introduced is significant? This is the only way to know. You check the p-value. You don't look at the graph. Now, okay, you know what could happen? Why the experience is not significant right now? Maybe there's another important variable missing. That is making sense, right? And that is the reason why, even though we're focusing on the effect of marital status on salary, we need to go into literature and identify some other factors that could affect wage. So right now, even though it's not significant, there's no problem. Okay. Now, take a look at this. I'm gonna do something now. Okay. Now, what I'm just explaining here is that looking at the model, if you take a look at it, this is just a plot. Okay, my TA is going to walk you through how do we generate a scatter plot where you have one response and two independent variable, and one is categorical. You can see in the status, you can see married, single. And when experience equal to 20, how much less does a single worker earn than a married worker on average? If I want to know, I'm going to go to a single worker model that I've generated here, and I'm going to put the experience, because each of this model now we have experience in it. Does that make sense? Okay, now that is exactly what I'm trying to say uh here. And let me tell you this. I need you to pay attention. We want to do something now. Please pay attention. Okay, take a look at this. Initially, when we did not consider experience, right? When we did not consider experience, what happened? The single worker lost 109 cents, right? And 109 cents less than a married worker on average per hour, right? Now, when we consider experience, when we now consider experience, what has happened? What has happened is only losing 90 cents, which means it's a single worker has gained because we have incorporated experience. And that was why, take a look at this. If I want to interpret that, I'm going to say, in other words, when we control for experience, controlling for experience is like incorporating experience as a variable into the statistical architecture. That is, we're holding that value of experience, a single worker hand 90 cents less than on average. Okay, so which means when you did not control experience, what happened? When you did not control experience, a single worker make 109 cents. Okay, now you mentioned something now, like what is happening. The experience here is not significant looking at the p-value. Maybe we are also missing another key or variable that could potentially affect the response. Then I'm going to consider others like years of education and the sector the worker belong, because the sector you belong in a company could determine your salary as well. Does that make sense? And if I want to do that, and if you take a look at The experience, the years of experience, the years of education, they are quantitative, but the sector the worker belong is categorical. And right now, we got so many levels of categorical, clerical, like 1, 2, 3, 4, 5, 6, 7, 8. But you know what? If you write a code in R, please pay attention. Please pay attention. If you write this code in R, is there anyone who doesn't understand that code? Super easy, just adding, right? Okay, if you add this code in R will automatically make one of the sector level to be referenced. Does that make sense? And now what we're going to know, the one R is going to reference, okay, the way to know that is going to be missing in the output. Please pay attention now. This is the output. What is missing? What sector is missing? Can somebody tell me? Do you see the blue one? I'm sorry, the yellow one? Which sector is missing? Let's go. Okay, let's go back. Do you see that? I'm gonna go back. Take a look at the sectors. Which one is missing? Is it clerical? Let's see. Oh my God, it's clerical, which means R has automatically coded clerical 0. Does that make sense? It has coded clerical 0. And you know, of course, you are still seeing this one. Okay, that is coded 1, and married is 0. Okay, so take a look at that. Now, there's something I want you to see now. You know, you asked a question the other time. Check now. When we consider other sector, experience is now significant. Do you see that? When you consider other important factor, the experience that was not significant before, if you look at the p-value now, for experience, that's significant. Take a look at that. Okay, now this is the way the arrow output is going to be. But you know what? If I ask you to write the feeder model, okay, I deliberately missing something. Of course, the first one that will be here will be this guy, will be the intercept, right? Does that make sense? And the second one, the one with the experience. So you just need a combination of this guy. That is what you're going to use to write your feeder model. Any question, whether in person or online? Oh, this is so easy. Okay, but ask question if you don't understand. Okay, this is the feeder model. But you know what? When we consider other variable, look at the state of single. It's no longer significant. So, which means when you work in a company, okay, your salary does not depend on whether you are married or not. But initially, when you did not consider when you did not incorporate, the really important covariate, what happened? It was significant, and that will mislead us. Okay, now, but I wanted to say something. I'm saying we're still focusing on this. Oh my God. Initially, when I only consider the marital status as only explanatory variable, the single worker hand 109 cents less than the married, right? When I incorporated experience, the single worker gain, right? And it was earning 90 cents less. But right now, what has happened? The single worker has gained again. How much is it? How much does he earn less now? 40 cents. Do you see negative 0.39? On average, that's a 40 cents. So which means when we consider other important, and that was why I said this. Take a look at this guy. I said, what is the conclusion now? Conclusion for the study of marital status and wage. Let me tell you this. The primary variable of interest is marital status. But along the line, we need to incorporate some other variables that could have effects on the wage. Okay, when we did not incorporate, I said, when not controlling for other labor force factor, the single workers make 109 cents less per hour than the married workers on average. Now, when controlling for experience only, the single worker make 90 cents less on average. When controlling for experience, years of education, job sector, and so on like that, what happened now? 40 cents. Do you see that? Okay, so what is the essence? Take a look at this. Okay, what can we learn from this example? What we can learn is it is very important to control for covariates. Even though I'm not interested in them before, I'm not interested in them initially. What I'm actually interested in is to investigate the effect of marital status on wage. But if I really want to get a clear picture of the situation, then I need to be able to investigate, to go to the literature, review article, and be able to identify some potential covariate that could also influence the wage. Okay, and that was why, if you take a look at this, the response variable is actually wage, and the variable of interest was status, but we realized that these are covariates. Covariates are variables that are also important, even though they are not the primary variable of interest. Does that make sense now? And controlling for covariates is especially important when you analyze data from an observational study. Now, do you know what we mean by with there are two types of study? We got observational study, we got experimental study. In observational study, we actually conduct survey where we use historical data. The researcher did not manipulate, okay? And observation study has some issues, okay, because of the fact that there could be bias, okay, with observational study. Let me give you this example. Another example. I want to look at the effect of uh, sales of ice cream on crime rates. Okay, what am I saying? I'm looking at the effect of sales of ice cream on crime rates. Do you know correlation may exist? Does that mean? Does that mean that maybe? Can you say because of the increase in the sales of ice cream that now causes the crime rate? No. You know why? Because there could be other potential variable that you did not consider, like weather. Whether you're in the rainy or you are in a fall, or you are in a winter or whatever. So if you don't control that, those are covariates. That's what I mean. Okay. So um okay, so I think that is I'm quickly gonna go into the next material. I'm gonna go into the next material. Let me give me 1 second. I'm gonna share the next material now. Oh, before going to the next material, is there any question? Oh, quick one. Go ahead. Oh, whether there's a graphing. Yeah, yeah. No, I think in when you are doing lab, the TA is going to tell you some. Even we have some packages that need to be loaded if I want to get this kind of structure. So, but everything can be done under the R interface. Are you using R Studio or just R? Oh, R Studio is, you're going to see a lot of, R is just like, I have a car, but do I put a gas in it? So there are some operation in that we may want to do that may not require loading package, but there are some that will require loading packages. But I want to believe in the material that I normally send to my TA, of course, it's gonna walk you through all of that. Yeah. Okay. I'm gonna uh, let me share a new material. Okay, gonna share a new material now. And even though if we don't finish this material today, oh, we got 15 minutes. I'm gonna see what we can do in 15 minutes. Okay, those of you online, I don't know, can you confirm if you see what I'm sharing, right? I think I just share. Oh, give me 1 second. Uh, why is it not? Why is it not showing now? Okay, so it should be showing here now. Okay, showing now, right? Those of you online, can you also confirm that? Is that changing, right? Is it changing? I need someone online to confirm if this is changing. I just want to know. Is it changing?
It says F test versus nested F test, and that's
You
all
said
we
what?
can see. You can see like the chapter 3 first screen, but nothing's.
Oh, okay. What about now? Like, do you say is it changing now? Is it changing or is not changing at all?
No.
Okay, so is it showing the first page, right?
Yeah, correct.
Oh, okay. Okay, let me see this. Why is it not changing? It's supposed to be changing as well. I'm going to remove. Let me see. Yep. Okay. I think I got this one now. Then I'm gonna share it. Okay. And after sharing that, then I'm gonna put this. Come on. Come on. Come on. Okay. So, let me see. That's uh, okay. So what about now? This of online. Is it changing now? Or is it still showing the same page? Is it changing now?
Um, it might still be loading.
Oh, it's not changing, right?
No.
Okay. Oh, let me see what I can do here. What about now?
Yeah,
Is
we
it
can see
changing
it.
now?
Yeah.
Yes, right?
Yeah.
Okay. Okay, so I want to welcome you into another material. This is F-test versus nested F-test. Please pay attention. Okay, now we want to differentiate between F-test and partial F-test. Partial F-test also called nested F-test. And when do we use that? Okay. Those of you watching online, can you confirm the page we have? Do you see review F-test in simple linear regression right now? Those of you online? Can somebody tell me what you're
You
seeing right
see where
now?
it says chapter 3 F test versus nested F test.
Okay, so that's what you see. Okay, I think I'm gonna change. At times this happen. Don't know. That is technology. Okay, so as that thing come up, can change it to. Come on. Okay, what I'm gonna do, I'm gonna reserve this material for tomorrow. Okay, so I think you have a technological issue now, so I'm gonna reserve that material for tomorrow. Okay, so is there any question based on what we've done today? Where we get the data set from? They are I uploaded a material. Do you on Canvas on other student resources? the data set. No, the data set we're using, we could use data set from internet. We could use the one from R. We got data set in R. If yeah, if you check there's what I call R companion that I share. That is the material the TA is using. So we have a way, let me tell you this. We if we there are several ways to get data into R interface. If the data set is in Excel, we have a code to write to bring it into our interface. If data set is online, if we know the link, there are some online. Of course, if I want to give you a data set from online exam, I'm going to provide you the link. Then there are some data set. If you check the arrow manual that I uploaded for you, we only need to load a package start2 data. And the way to do it is that's why I needed to go to the student resources section of the module. Okay, I attach the arrow material for the lab. Okay, because getting data is very, very compulsory. I mean, it's very, very essential because you can't do anything without you having data. Okay, so this is where I'm going to stop today. The other material I'm going to discuss. Is there any question whether in person or online? Any question whether in person or online? Okay, assignment 3 will be uploaded today. I delay assignment 3 because I extended assignment 2. I don't want you to have two assignments at the same time, It doesn't make sense to me. So, okay, make sure you all stay safe and have a lovely day. See you tomorrow. Bye for now, everyone.
Thank you.
You're
Thank
welcome.
you.
You're welcome.